right, welcome back. This is going to be the last unit that we're covering before we have our first official proficiency check, Proficiency Check 1. We have to cover something called literal equations and formulas. And so, the end of this lesson, you should be able to say, I can solve for any variable in an equation or a formula. And that's going to sound weird, any variable. I know that we've been doing variables on both sides, and so you're used to, you've seen more than one variables. But when I say any variable, we're talking about different variables. And I'm going to explain that in a second. So let's really quickly, literally. Literally means, for instance, this is a mouse. But what's on my mouse? A literal mouse. So that's literally a mouse. This is called a mouse. This is literally a mouse. Literally means the actual thing. So what we're going to do is, this lesson is a really hard lesson for a lot of kids. In-class kids, we spend a lot of days on this. Since you're at home, or if you're just doing this as a review, you may not have as much time. We're going to try to break this down as much as we can and make this as simple as possible. So, really quickly, you should pause and go ahead and write these notes down. And then I'm going to keep talking. I'm going to assume that you've already paused and you've already written these notes down. So it says a literal equation is an equation that contains more than one variable. Let me give you a really simple example. You may have remembered this from maybe the 3rd grade, 4th grade. Area equals length times width. Area equals length times width. There are a lot of formulas. We could do area of a circle equals pi times r squared. Those are literal equations. The reason why they're literal equations is because I don't know the answer to the specific circle that I may be thinking of, or the specific rectangle that I'm looking at. This is just the literal equation. Once I have a rectangle, for instance, and this is 8 maybe, and this is 3, that's when I can come in and say, well, this is my length, and this is my width, so I can take that information and put it in. 8 is my length times 3 is my width, and I can find the area from there. So that's when I put it into the equation. But the literal equation is just variables. And so people say, okay, I kind of get that, Mr. Craig, but where are you going with this? Well, here's where I'm going with this. Sometimes I have the length and the width and I need to find the area. But sometimes I have the area and maybe I have the length and I want to find the width. Or maybe I have the area and the width and I need to find the length. And so what happens is, instead of, in this equation, when I plug in values like, 8 and 3, I'm solving for A. I'm trying to find what A is. What's the area? But say I say area is 24, and I know the length is 8. Oops, that's not supposed to be at times 8. What is the width? So now I'm solving for, so here when I plug this in, I was finding out what A is. But here, when I'm solving, I'm trying to find what W is. So a literal equation means that I'm looking at the basic equation, and then I have to figure out what I'm solving for. And usually, you either know it, or we're going to tell you what it is. So let me give you an example of that. So I'm going to start off with really easy stuff here. This is, oops, I didn't want to do that, but that'll work. This is a one-step equation. It has one variable. You're like, Mr. Craig, you just said literal equations, and that's not a literal equation. That's a one-step equation. Yes, you're right. I'm going to use that to show you how to do a literal equation. So, if this was an equation I was solving, I would start by going, my lollipop. And so I draw my lollipop that divides my equation into 2 equal sides. Then I look for the variable. Oh, there's the variable. I'm going to circle that variable. That is my variable. That means that's what I'm solving for. And then I look, hey, this has no coefficient. Well, it has a coefficient. It has that invisible 1. But since 1 doesn't change the problem, I don't really need to worry about that. I could put a line underneath it and say, oh, it's a 1 there, but it doesn't matter. And then I look and say, what else do I have? Well, what's on the same side but not touching it? Well, that's the 4. That makes the 4 the constant. And so to solve, it's 2, 1, 0. And to get rid of a constant, we always add or subtract. So we have a 4. And so how do we get rid of 4? We subtract 4. And if we do it to one side, the subtraction property of equality says we have to do it to the other side. So I have minus 4 to both sides. 4 minus 4 is 0. So I put a 0 there, but I don't need to write the 0 down here because you don't need it. I mean, you can tell people, hey, I'm 15 plus 0. And it could be true, but they'd look at you like you were crazy. So, this is 0. I bring down that m. That's my variable. 12 minus 4, I can solve that. That's 8. And so now, because m is alone, I don't have a coefficient I need to get rid of, I'm down to my answer. My answer is 8. You're like, Mr. Craig, that's really simple. So let me show you on a literal equation, and you're going to go, oh, what happened? So here is a literal equation. In a literal equation, I have all variables. I don't know what h is. We kind of just made this up. So h plus m equals w. And so you're like, oh crap, Mr. Craig, what do I solve for? I don't get it because you're supposed to solve for the variable. Well, that's where you need to pay attention to the instructions. Sometimes you'll know what you're looking for, like if you're looking for the area of a shape or the length of a shape. But sometimes they're going to tell you, solve for m. And so if I'm solving for m, that's the variable that I want to get alone because I want to know what that equals. So here we got m alone and equaled 8. Here I want to get m alone. So I circle m because that's my variable. Well, what should I have done before? Them lollipops. And so I circled m and I'll say, okay, you circled m, Mr. Craig, now what? Okay, is there anything touching m? There's the symbol plus. That means that there's an invisible 1 there. So just like in this problem, because these really are the same problem in a lot of ways, m has a 1 in front of it. I don't need to worry about that. Then the next thing we look for is we look for the constant. And the constant is the thing that's on the same side as the variable but doesn't touch it. Now you're saying, well, that's a variable, Mr. Craig. You're right. But since we're not solving for h, we pretend that it is a number. So I say m is my variable, no coefficient. I got to solve for h. Okay, I got to get rid of h. And so h is a constant. And so I underline that twice, just like we did here. And now I'm ready to solve. Step 1 is get rid of the constant. That's the 2 lines. How do I get rid of h? Well, the opposite of h, if it's a constant, all constants are gotten rid of by adding or subtracting. So I'm going to subtract h. If I subtract h from one side of an equation, the subtraction property of equality says I have to do it to the other. So it's again, just like this side. However, I'm doing it with h's. Now, I don't care what h is because h minus h is always going to be 0. So that becomes 0. I don't need to bring the 0 down. I do bring the m down. And now, here's part over here, because they were both constants, I could go 12 minus 4 and say, oh, it's 8. But here, it's a literal equation. W minus h is, I don't know. Because I don't know what w is and I don't know what h is. So all that I can write is what I literally see. I see that w minus h. That's what it is. W minus h is w minus h. Until I have numbers that I can put in there like 12 and 4, that's what it is. So I know that m equals whatever w is minus h. That's what a literal equation is. Now, once I've done that, I can evaluate m, meaning I'm going to solve for m. It says, okay, well, what are you going to do if I told you h was 10? That means I would go back to my problem now, and I'd say, okay, h is 10. I'm going to go to my problem and substitute the h with a 10. See how I put it in parentheses? I always put it in parentheses because I don't want to make a mistake and mess up the sign. So I bring down that minus from the equation, and it says, and w is 7. So I'm going to substitute the w with a 7. And so now I can solve that. What's 7 minus 10? Well, 7 minus 10 is negative 3. So now I know m equals negative 3. And I did that because I took m, got it alone, and then I evaluated it and substituted those values in to find out what m was. Here, I didn't know what it was. I knew m was just w minus h. But when I found out what to plug in there, now I was able to do so. So let's try another one. And again, we're going to do simple. I know if this is too easy for you, you can jump to the next video. Mr. Nelson's teaching it. He's much better. All right. Here is another basic problem. This is a one-step equation, again. And again, there's only one variable. And you're like, Mr. Craig, we already know how to do this. But we're using this to show you that little equations can be just as easy as a one-step equation if you know how to proceed with it. So this time I'm going to start right off the bat with my lollipop. Right? And so now I go, okay, what is my variable? Well, I'm solving for w, and there's only a w here, so nothing to worry about. There's a w. Now, once I find out that I'm looking at this side of the equation because the variable's on this side, I have to say, okay, what is on the same side of it? Well, I see there's a 2 touching the w. If it's touching the variable, that makes it a
coefficient.
Coefficient. And so I know this is a coefficient. We underline our coefficients, right? And then I say, okay, is there a constant? A constant means something that's on the same side. So this is a constant, but it's not on the same side of the equation as the w. So there's no constant to solve. So we're supposed to go 2 lines, 1 line, 0, get rid of the constant. Well, there is no constant, so that's done. Then we're supposed to get rid of the coefficient. How do I get rid of the coefficient? Well, it's times 2. How do I get rid of times 2? I divide by 2. And if I divide one side by 2, the division property of equality says I divide the other side by 2. And so I do that. And 2 divided by 2 is 1. That leaves me a w. And now I know that w equals 3 over 2. Which, by the way, you can leave it that way. If you want to switch it around, you can write this as w equals 3 over 2. Because a lot of times on tests and whatever, the variable's on the left. And if you want to, you could change this into w equals 1 1/2. But you will find as we move forward that turning improper fractions into mixed numbers actually makes problems more difficult. But that's good. Pretty simple equation, right? Let's look at it again. So now we're looking at a formula. Just like at the beginning of this thing I said area equals length times width, right? So you're like, oh my gosh, this is all variables. What am I doing? Well, it tells me I want to solve for w. In this case, I want to find the width. I'm looking for width, so width is my variable. Again, I'm going to start off by doing my lollipop. And I've divided into 2 sides. Now I'm saying, okay, w is the variable I want to solve for. So even though these are all variables, I'm only solving for w. Now, you say, but there's still letters here. Again, as soon as we identify what variable we're solving for, we just pretend all the letters are just numbers. So I say, okay, L is touching w. If L is touching w, that makes it a coefficient because coefficients touch the variable. So L must be a coefficient. So I know then I have to underline L. Next, I would underline a constant, but I don't have a constant. So I'm done. So now I got to go to solve. I solve, get rid of the constant. There is no constant. Get rid of the coefficient. The coefficient is L. How do I get rid of times L? Well, to get rid of times L, I divide by L. And if I divide this side of the equation by L, the division property of equality says I have to divide the other side by L. L over L doesn't mean, that sounds like laugh out loud, is 1, right? And what's left is W. But over here, I don't know what A is. I don't know what L is. So all I can do is say, I know that W equals A divided by L. As soon as I know what that is, I can tell you what W is. And you say, okay, so why do we do that? Well, now if I say evaluate W when A is 40, so they're saying substitute A with a 40. And then L is 5, so I'm going to substitute the L with a 5. And I know that's going to equal W, right? Now, here I couldn't do anything, right? I didn't know what it was. But now that I have these values, I can say, okay, 40 divided by 5 is 8. So W must equal 8. And you can write it this way, or you can flip it around and put the W on the other side. My answer is 8. That completes the first part of it. If you got this, move on, do those questions, and then watch the next video brought to you by Mr. Nelson.